Hello. This tutorial covers the Unit 9 review worksheets. So you should already have this top part filled out. Number 2, what's the difference between lateral area and surface area? The surface area of a figure includes a certain area of part or parts that the lateral area does not. So that will be your hint on that one. Number 3 and 4, we are asked to find the surface area of these two figures. And so what you need to do is, for the rectangle, we're going to find a rectangular prism. So we would find the area of all 6 faces. All right, so you're going to have, so you got 6 faces, and then 2 of them are going to be identical. So 3 sets of 2, meaning this side and this side will be the same, this side and that side will be the same, and then this front side and the back side will be the same. So what you're going to do is basically write out 3 rectangles like this, okay, and you'll have your dimensions. So you've got 11, and then this is going to be right here by 1.5, then you've got 11 by 6, so that's what this big one is, 11 by 6, and then you've got this, these on this side's 6 times 1.5. So basically what you do is you have 3 values, and you just multiply each number by itself. Okay, so remember, once you get that, you're going to multiply each of those by 2, and then add them up. Okay, now that's going to be for your surface area, and then for the lateral area, lateral area is going to include everything but the bases, and let's make the bases for this problem the larger rectangle. So you just would not include those right there for the lateral area. Okay. All right. Number 4, you are going to have to find. You got 2 circles. So you got 2 of those, and you got a rectangle. And then remember, for the circles, it's just the area. It's pi r squared. Okay, and you got the radius right there, so remember, once you get that, to multiply it by 2. And then for the rectangle, 26 is going to be the small part of it, and then remember the long part is going to be 2 pi r, the circumference of that circle. So you just plug 11 in right there, multiply those together. There's just one of those, so then you're just going to add those up. That's going to be the surface area. Remember, the lateral area is just that part of it right there. Okay, so lateral area does not include that. All right, let's see. Number 5, those should be pretty straightforward. 6, determine the volume. All right, so for this one, the volume is going to be the area of the base times the height. So you've got to find the area of the triangle, and the tricky part about that is, okay, so it's an equilateral triangle, 12, 12, 12. And so what you're going to need to do is use the Pythagorean theorem. Sorry about that. Use Pythagorean theorem to determine the height right here. So what I'm going to do is I'm going to redraw this triangle there. All right, so that's going to be 12. That's going to be 6. Now you can either use the Pythagorean theorem to get this side right here, so it'll be height, or you can use your shortcuts. So remember, this is going to be a 30, 60, 90 triangle, and we multiply this times radical something to get this. So that's the 2 ways you can do it. So once you get this, this is the height of the base part right there. So remember, area of a triangle is base times height divided by 2. So that's going to go right there. That's your base. That's more than enough help for that problem. All right, number 7, what's the volume for this? So you're just going to find the area of the base times the height and multiply them together. So that should be pretty easy. Number 8, just fill out those formulas. 9, find the height of the pyramid if the volume is 88.5 cubic centimeters. So we'll work backward on this one. So its volume is going to equal the area of the base times the height. So we're looking for the height. So what we're going to have to do is plug in everything from V and B. So this is going to be a square right here, so that means that's going to be 8. So you determine the area of the base, the volume goes there, and then you solve for the height. 10, volume of the cone. Oh, forgot something. Gotta divide by 3. Okay. 10, so volume equals area squared, height divided by 3. Okay. So just main thing to watch out for here is to make sure you use 2.5 as the radius. All right, you can go ahead and figure that one out. Find the volume to the nearest foot. So you're just going to use the formula. So it's 4 pi r cubed divided by 3. It's going to be up on the board. So this is going to be the diameter. So you just need to make sure you convert this. 4.3 is the radius, and then you just plug it in there. All right, 13. Coca-Cola wants to recreate spherical bottles, so they have decided to design 47%, diameter 5.5 inches. How many materials? So, so this is going to be surface area. So you're going to need to find the surface area of the sphere. And then you use the formula, and you're just going to make sure to use, so 5.5 is the diameter, so 2.75 is the radius. Okay? So use the formula for surface area for a sphere. It's 4 pi r squared. And then you're going to have to multiply whatever you get. Make sure to multiply it by 0.47. So that's what you'll do there. Let's see, 14. This should not be here. Oh wait, it should. I apologize. I don't know what I'm doing. Okay. Square pyramid, base edge of 12. So it's 12, 12, altitude of 17. So the height 17. Both the pyramid and the cylinder are the same height and volume. What's the diameter of the cylinder? So what we're going to have to do is find the volume of this pyramid. So find volume of the pyramid. So you got the height there. So you got everything that you need here. So volume is base times height divided by 3. Okay, so you got your base. That's the height, 17. Okay, so you're going to use this volume, and then over here you're going to have pi r squared divided by 3. So whatever the volume get, use it there. And then it's also height. You're going to use the height also there. You're going to solve for the radius, and then you're going to have to multiply it by 2 to get the diameter. All right, 15. I don't like this question, so we're not going to do 15. 16. So Daniel has an aquarium. It's filled 2/3 of the way, so the level is at 4 inches. And if he wants to fill it up so it's completely full. So how many more cubic inches do we need to add to the volume? So you're going to find the volume with the height there first. And then you were going to find the volume with this, and then you're going to subtract the 2. So first problem, use 4 as the height. Use those 3 dimensions. Where volume equals length times width times height. Okay, and then the next time use 6, and then you're just going to subtract the 2. So use 4, and then 6, and then subtract the 2. All right, number 17. He's got an aquarium. What would be the height of the water poured from the old aquarium to the new one? Seeing the base of the equal outside. All right, so what you're going to do is you're going to take from whatever number that was, 14. So you take the volume from 14. Yeah, whatever volume you had on 14. You're going to use it there. And then you're going to need to, does it ask us to find, what's the height? Is that what it asks us? Yes, so this is what we're gonna figure out. So you need to figure out the base area, the base. This is gonna be, so this is an equilateral triangle. You'll do this one just like number, just like number 6. All right, so do it just like we did that. Okay, instead of 12, you're gonna use 5. So create an equilateral right triangle, draw it out over here, Pythagorean theorem. That gives us the height, and then you'll multiply by 5 to get the base of the figure, of the triangle, and then you use that to solve for h. 18. One's basketball has a diameter of 9.23, and is 9.51. Difference of the volume. So volume equals 4 pi r cubed divided by 3. So you need to do this twice, once with that, and once with that, and then subtract the 2. But make sure we take half of this and half of this for the radius. 16. So I'm going to pause it for now, because otherwise the video won't load. I'll make a part 2.